While designing an efficient chiller plant, it is of utmost importance that chiller selection is done with energy efficiency as the front and center of the design. Why? Because it accounts for 30 to 60% of a building's total energy consumption. The chiller selection is done by looking at the loading pattern of the site, and usually only the peak loading is given importance. Is this the proper way to go about this process? Let us take you through an example. A key point to keep in mind is that at different loading percentages, a variable speed water-cooled screw chiller, which is one of the most efficient and used type of chillers, will have different kW per TR values. Take a look at this graph, which is plotted from actual data from one of our southern Indian sites collected over 8,760 hours using our state-of-the-art IoT system, Joules. It is evident from the graph that kW per TR values are best in the range of 20 to 59% loading. Also, the kW per TR value is worst at peak or above 70% loading. Now let us look at the actual loading data from the same site over the same time period. It is evident from the graph that the chiller runs a total of 5,366 hours or 78% of total run hours between 30 and 59% loading in a year. Also, it ran for very few hours between 80 and 100 or peak loading during the same time period. To sum it up, while comparing different models of chillers, one should pay careful attention to the design chiller kW per TR values, not at the full load but at the most operational loading band. So this is just one of several ways in which smart Joules helps reduce the energy consumption of large facilities.